Hi everybody. Once again I am here with the continuation of class 9 physics. In my previous video I have taught you the chapter force and laws of motion, and the first topic was Newton's first law of motion. Today I am continuing with the second point, momentum. What is momentum? In simple words, if I explain momentum, I can state it like this. Momentum is the impact of a moving body. The impact of a moving body is called its momentum. I will explain it with a simple example. Suppose you are hit by a cycle moving at a speed of 5 km per hour. You may not get much hurt. But if you are hit by a truck moving with the same speed of 5 km per hour, you may get severe hurt. What is the reason? Less mass of cycle and the huge mass of truck. Even though the speed of both the vehicles were same, the huge mass of truck can make more impact on you when you are hit with. So the first point, the impact of a moving body depends upon its mass. Now let me take another example. If you are hit by a bullet coming out of a gun, you know the mass of a bullet is very less. It is in grams. But a fast moving bullet can kill you. Reason? Speed. The high speed of bullet is making it very harmful. It can pierce into your body. So we have seen two things here. First one, mass of the body can decide the impact of that moving body, cycle and truck. Second example, a less mass but fast moving bullet can kill you. Here the reason is fast, that means speed, or in other words we can say acceleration. The rate at which velocity was increasing. When the bullet is fired from the gun, then its acceleration, the rate of acceleration is very high for a bullet. So I am coming back to our point. What is momentum? Momentum is the impact of a moving body. Now how is it defined? Momentum of a body is defined as the product of its mass and velocity. Product of its mass and velocity. In my first example, mass is the reason for the impact. In the second example of bullet, velocity is the factor that decides the impact. So both mass and velocity decides the impact of a moving body. So momentum is the product of the mass and velocity of a body. Momentum is represented by small letter P. So momentum P is equal to mass into velocity. So the formula for momentum is P is equal to M into V or mv. Now let's see its SI unit. SI unit of mass is kilogram. And SI unit of velocity is meter per second. So what is the SI unit of momentum? It is kilogram meter per second. So momentum P is equal to M into V or mv, and its SI unit is kilogram meter per second. Is it clear? So the impact of a moving body is called its momentum. It depends upon two things, its mass and velocity. I have given you two examples to illustrate how the effect of mass and what is the effect of velocity. Okay. Now I am moving to our next topic, that is Newton's second law of motion. Actually, this topic momentum is taught for defining Newton's second law of motion. So, we have discussed first law of motion. Now today, Newton's second law of motion. Yes, in the same way, I have explained Newton's first law of motion with various examples. Before coming to the statement of Newton's second law of motion, I am once again explaining it with an example. You may be knowing that if a car has a dead battery or no battery, it cannot be get started. Then you might have seen the people are pushing the car. After pushing the car for some time, it can be get started. There is a system for getting it started. But you might have seen, if only one person is engaged in this pushing, the car may not get started. What is the reason? A particular speed is required for the car to get it started. The force applied by a single man is not enough to make that speed on the car. So the car does not get started. So what do? We may call one more. Two people came, again push the car. If they are able to make the required speed on the car, it can be get started. Obviously, this time the speed will increase. Why the speed is increased? Because two people are involved in pushing. Not only speed, but what will also increase? Momentum of the body will also increase. We have already studied momentum is the product of mass and velocity. So when velocity increases, momentum will also increase. Mass remains same because the same car. So why the momentum of the body increased in second case? Because two people were involved in the pushing. When two people are involved in the pushing, what is actually increased? The force applied is increased. Is it? Now you call three people. When three people are involved in pushing the car, the momentum of the car will increase very fast. Then the car can be get started. What is the reason here? Three people are involved, so the force has become tripled. So when more force is applied, the momentum of the car is increasing at a rapid rate. So I am coming to the conclusion. The rate at which the momentum of a body increases depends upon the force applied on it. I repeat, the rate at which the momentum of a body increases depends upon the amount of force applied on it. This is Newton's second law of motion. So what is Newton's second law of motion? The rate of change of momentum of a body is directly proportional to the amount of force applied on it. I am not writing it, but you listen my statement and you have to write the same statement. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the amount of force applied on it. So mathematically we can say, suppose a body of mass m, small letter m, has initial velocity u, and by the application of force F for time t, small t, its final velocity has become v. When you explain Newton's second law of motion, you have to write all this. First you write the statement. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the amount of force applied on it. Now you can write in the next paragraph. Let a body of mass m has initial velocity u, full stop. By the application of a force F, capital F, for time t, let its velocity, final velocity has become v. Now, Using Newton's second law of motion, F is proportional to rate of change of momentum. What do you mean by rate of change of momentum? Final momentum minus initial momentum upon time. Rate of change of velocity is called acceleration. What was the formula? Final velocity minus initial velocity upon time. Similarly, rate of change of momentum means final momentum. So what is final momentum? mv. If v is the final velocity, final momentum is mv. And what is initial momentum? mu, because u is initial velocity upon time t. So this is the mathematical statement of second law of motion. F is proportional to mv minus mu upon t. First you write in statement. Force is proportional to final momentum minus initial momentum upon time taken. Now give the mathematical notation. Now I am taking m common. So it is v minus u upon t. We know that v minus u upon t is called acceleration. So we got F is proportional to ma. And we know that whenever there is a proportionality sign, we will change it into equal to sign. How? With the application or with the introduction of a constant, which is known as constant of proportionality. Here the constant of proportionality is small letter k. Whenever the proportionality sign is converted into equal to sign, there will be always a constant. And here the constant is k. So we can write F is equal to k into ma. Now, the scientists have calculated the value of small k in SI unit. How? By putting m is equal to 1 and a is equal to 1, they have calculated the force exerted on the body. And they got when m and a are 1, then the force is also 1. So what is the value of k? That means the value of k in SI unit is 1. Since the value of k in SI unit is 1, what can you write? F is equal to 1 into ma, or we can write F is equal to ma. So this is the mathematical derivation of Newton's second law of motion. And finally we can say Newton's second law of motion means F is equal to ma. Force applied on a body is the product of its mass and acceleration. Force is equal to mass into acceleration. What was the statement? The rate of change of momentum of a body is directly proportional to the amount of force exerted on it or applied on it. That is, F is proportional to rate of change of momentum means final momentum minus initial momentum upon time. That is mv minus mu upon t. Taken m common. V minus u upon t is called a. So F is proportional to ma. K is the constant of proportionality. SI unit of k is 1. So F is equal to ma. Got it? Yes. Now, I'll give you another example to illustrate Newton's second law of motion. Practical example in our life. You might have seen when the professional cricketers are taking the catch, they are not taking the catch by holding their hand fixed at a place. Is it? Did you notice in international matches or in professional matches, they complete the catch by lowering their hand. They may start the catch at their overhead. Now along with the ball, they will bring down the hands and they will complete the catch here at the bottom. They take the catch like this. Is it? Why do they do so? It is an application of Newton's second law of motion. Look here. F is inversely proportional to time. Whatever is in the denominator is inversely proportional. So force is inversely proportional to time. What does it mean? When time increases, force decreases. By lowering the hand along with the cricket ball, we are giving more time to that ball to stop. When more time is given that ball to stop, less force will be exerted by the ball on your hands. So you will not get hurt and you can comfortably complete the catch. If you hold the hands at a particular position, the ball will fall on your hands. It will hit with great force because you are not giving any time for that body to stop. You are suddenly stopping the ball. So their T is very less, fraction of second. So F will be very high. So with great force it will hit your hand. It can slip away, it can hurt you and you won't be able to complete the catch. But by lowering the hands along with the ball, you are giving more time for the ball to come to rest. When more time is given, less force is applied. That body will exert less force on your hands and you will not be get hurted and you can comfortably complete the catch. There are so many more examples of Newton's second law of motion. So I think the points are clear to you. We have discussed what is momentum. Momentum is a product of mass and velocity. P is equal to mv. Its SI unit is kilogram meter per second. What is it exactly? It is the impact of a moving body. When we are hit by a car, we get hurt because of the momentum of the car. So I told you, if it was a car that was not moving, we will not get hurt. Reason, V is equal to 0, so momentum is also 0. Then I have told you two examples, a cycle and a truck. We get more hurt because the mass of the truck is more. Now the bullet can even give us more hurt. Reason, velocity. So mass and velocity are the two factors that decides the momentum of a body. So we got the formula P is equal to mv, m into v. Both are directly proportional to P. When any one of these two increases, P will also increase. Then we have come to Newton's second law of motion. This is all about Newton's second law of motion. So that's all for today. Momentum and Newton's second law of motion. Please make a detailed note of it and try to find out more examples of Newton's second law of motion. So please take care of yourself. Thank you for watching and please make the notes of what is taught today. Bye.